class, I thought I'd make a video going over the answers to the 6895-99.7 worksheet. This is for the 6895-99.7 rule for normal curves. So it's important to remember that the 6899-99.7 rule is discussing the percentage of data under a normal curve. Remember that the total area under a normal curve is 1. So what this is telling us is within the first standard deviation, remember we denote that with a sigma, within the first standard deviation we have 68% of the data. That means that the area between the first standard deviations is 0.68. It tells us also that we have 95% of the data within the first 2 standard deviations of data. So that means that the area under this portion of the curve is 0.95. Lastly, this rule tells us that within the third standard deviations, we have 99.7% of the data. Okay, so the area under this part of the curve is 0.997. We can convert these decimals to percentages pretty easily. I also found this graphic online to kind of give you a breakdown of what's in each section, what percentage of data is within each section of the standard deviation. So between our mean and the first standard deviation over here, we have 34% of the data, so an area of 0.34. Between this, we have an area of 0.34 as well, right? And that adds up to 0.68. So there's 68% of data in the purple part. Now, if we have within the first 2 standard deviations, we have 95% of the data, right? 0.95 is the area, right? So if you take 13.5, 13.5, 34, and 34, that's going to add up to 95 or 95%. And then also within the third standard deviations, right, we've got 2.35% of data, so 0.0235, 0.0235, and so on. So this kind of helps you figure out how the sections are broken out into percentage by deviation. So the first problem on this worksheet states that a competency test has scores with a mean of 80 and a standard deviation of 10. So I'm going to go ahead and sketch this distribution. I'm going to pick a color other than red because red's kind of angry. All right, so here we have our normal curve. Our mean is in the center always, right, and that's 80. And I want to put in my first 3 standard deviations. So if I go up 1 standard deviation, I'm at 90. If I go up 2 standard deviations, I'm at 100. And if I go up 3 standard deviations, I'm at 110. We're also going to want to go -3 standard deviations as well. So if I go 1 standard deviation below the mean, that's going to give us 70. If I go 2 standard deviations below the mean, that's going to give me 60. And if I go 3 standard deviations below the mean, that's going to be 50. Okay? And your sketches don't have to be perfect. Lord knows mine isn't. But it's a good way for you to see what's going on with your data. So the first thing I want to find is where do the middle 68% of test scores fall? So I know that the middle 68% of test scores fall within the first standard deviations, right? So here is 0.68, or the middle 68% of data. We say the middle because it's in the middle. So between what 2 scores does the middle 68% of data fall? That's going to be between 70 and 90. Next, I want to know between what 2 scores do the middle 99.7% of data fall. We'll do this one in orange. That's going to be within the first 3 standard deviations, right? That's what the 68, 95, 99.7 rule says. So in between these 2 orange lines right here, we've got an area of 0.997, so 97% of the data. So this is going to fall between scores. I made a little mistake. We'll erase that. So that's going to fall between the scores of 110 and 50, right? We need to go 3 standard deviations. I'm going to write that from 50 and 110. Now, how high must your score be in order to be considered within the top, I guess we're going back to red, within the top 2.5% of data? Okay, so I want to know where over here does the top, on this side, right, where does the top 2.5% of data fall? Now, let's remember that within 2 standard deviations, I have 0.95% of data. So if I have my total area under my normal curve, which is 1 minus 0.95, that's going to give me 0.05% of data left. Or is it 0.05 area, or 5% of data is left. Now, that 5% of data is split between here and here, right? Because normal curves are symmetrical. So if I have 0.5% left over, that means I have 0.05 divided by 2 on this side and 0.05 divided by 2 over here. That's going to give me 0.025 or 2.5%. So on the left, this is our lower 2.5% of data, and on the right, this is our top 2.5% of data. So in order to score in the top 2.5% of data, you must have a score of 100 or greater. Now, for our next problem, let's go ahead and graph this. The Army reports that the distribution of head circumferences, a funny thing to measure, among male soldiers is approximately normal, with a mean of 22.8 inches and a standard deviation of 1.1 inches. So we're going to sketch our normal curve the exact same way. We're going to put our mean in the center, that's 2.28, and I'm going to want to go up 3 standard deviations and down 3 standard deviations. Okay, so if I add 1 standard deviation to 22.8, that puts me at 23.9. If I go up 2, that puts me at 25. And if I go up 3, that puts me at 26.1. I'm going to do the same for the negative standard deviations to the left, but I'm subtracting our standard deviation. That puts me at 21.7, 20.6, and 19.5. And I want to figure out what percentage of soldiers have a head circumference greater than 23.9. So 23.9 marks our first standard deviation. If I have all the data within the first standard deviations, that's going to be 0.68. Remember that this is symmetrical, okay? So I'm going to want to know how much data is left over in the tails, right? We're going to call these tails. So I take 1 minus 0.68. That leaves me with 0.32. So I've got 32% of the data in these tails. However, I have to divide this in half. So I've got 0.32 divided by 2 over here and 0.32 divided by 2 over here. That's because our graph is symmetrical. So if I divide both of these by 2, I get 0.16 on both sides. So if I wanted to know what percentage of soldiers have a head circumference greater than 23.9, it's going to be the area in this tail over here, which is 0.16, so 16%. Next, what if I want to know what percent of soldiers have a head circumference between 21.7 and 23.9 inches? Well, each of those mark our first standard deviation, right? So it's going to be this area right here, which is 0.68. So 68%. Last but not least, I want to know what percentage of soldiers have a head circumference less than 26.1 inches. I'm going to clean up our mess a little bit so we have room to see what's going on. The joys of technology. There we go. All right, so now we're all picked up a little bit. Okay, so let's do this one in red. So what percentage of soldiers have a head circumference less than 26.1 inches? So here's 26.1 inches. I want to know the area less than this. Well, 26.1 marks our first, second, third standard deviation. I know that the third standard deviation marks 0.997 or 99.7% of data. So I need to figure out the area in this tail over here. If I take 1 minus 0.997, that leaves me with 0.003. So that's going to be the area in both of these tails. But again, I have to divide it by 2 because it's symmetrical. So I'm going to take 0.3003 divided by 2 on both sides. That gives me 0.0015 is the area in each of these tails. Okay, I can convert that to so now if I want to find the area less than 26.1, I can take 0.997 plus the area in this tail over here, 0.0015, and that gives me 99.9985 or 99.85%. All right, for problem 3, the length of a human pregnancy from conception to birth varies according to the distribution that is approximately normal with a mean of 266 and a standard deviation of 16 days. So I want to go ahead and sketch this normal distribution. I'm getting better at this. Okay, my mean is 266. I'm going to mark my first, second, and third positive standard deviations and my first, second, and third negative standard deviations. So that's going to give me 282, 298, and 314. If I go down, that gives me 250, 234, and 218. So remember what I'm doing over here is I'm taking my mean and I'm adding 1 standard deviation, 2 standard deviations, 3 standard deviations, and then I'm subtracting 1 standard deviation, 2 standard deviations, and 3 standard deviations. So between what two values do the middle 68% of all pregnancies fall? Well, our middle 68% of data is marked by the first 2 standard deviations. The first standard deviation. So that's going to be between the values of 250 and 282. How short are the shortest 16% of all pregnancies? So remember that these represent days, right? We've got 218 days, 234 days, 250 days, and so on. 0.68 falls within the first standard deviation. If I take 1 minus 0.68, that gives me 0.32. So that's going to be the area in the tails over here. But I have to divide that by 2 in order to get the area in each individual tail. That leaves me 0.16, which we can convert to 16%. But I want to find the shortest 16%. So because these represent days, the shortest would be the least amount of days. So it's going to be this tail over here. So it's going to be any pregnancies less than 250 days. Now I want to know what percent of pregnancies last between 234 days and 314 days. So 234 days marks our second standard deviation, right? This has 0.95% of the data, but I want to know the area that includes this over here. I need to know what the area over here is. Well, our third standard deviation marks 0.997% of data. So that's for 3 standard deviations. This one's for 2. Let's think a minute about what the mean does for the normal distribution. So what the mean does in the normal distribution is it divides it in half. So the area over here would be 0.5, and the area over here would be 0.5. Our mean does the same thing over here. So I'd want to know what half of 0.95 is plus half of 0.997. So I have 0.95 divided by 2 plus 0.997 divided by 2. That's going to give me 47.5 plus 0.475 plus 0.498 equals 0.9735, which is 97.35%. The last problem discusses SAT scores. So SAT scores are normally distributed with a mean of 450 and a standard deviation of 120. This is our sigma, and this is our mu. So I'm going to go up 3 standard deviations and down 3 standard deviations. These sketches are getting rough, huh? So I have 570, 690, and 810, and I have 330, 210, and 90, right? This is plus 1, plus 2, plus 3 standard deviations, minus 1, minus 2, minus 3 standard deviations. So I want to know what percent of scores lie between 210 and 690. Well, that marks our second standard deviation, okay? So that's going to be 95% of our data. Next, I want to know what percent of scores lie between 450, that's our mean, and 570. 570 marks our first standard deviation. So within the first standard deviation, I have 68% of the data, or an area of 0.68. The mean divides that in half, though. So I'm going to take 0.68 divided by 2 to figure out the area over here. That gives me 0.34, or 34%. I'm going to do the same thing for our next question, but I feel like we deserve a brand new, clean graph, don't you guys? Okay, so now I am looking for what percent of data values fall between 450 and 690. 450 is our mean. 690 marks our second standard deviation. So how much data is within the first 2 standard deviations? What's the area here? The area here is 0.95, which would be 95% of our data. But I want to know the area of this half over here. So I'm dividing the 95 by 2. So if I take 0.95 divided by 2, that's going to be 0.47.5, which is 47.5%. Last but not least, I want to know what percentage of scores lie between 210 and, let's do this in orange again, 210 and 570. So 210 marks our second standard deviation. If the area over here is 0.475, then the area over here is going to be 0.475. What do we think the area between 450 and 570 is? Let's erase a little bit. So I know this is our mean. I've got 0.475 over here. 560 marks the first standard deviation, right? And we already calculated the between 450 and 570, we have 34% of the data. So I'm going to take 0.475 plus 0.34. That gives me 0.915, or 91.5%. percent.